All right, it's 5 o'clock, so we'll go ahead and get started. We only have a couple people in here so far, but that's fine. It is being recorded, so if you're not able to attend, you can always watch the video later. All right, so let's first start talking about this week's material, which is all about strings. So what exactly is a string in Python? Well, a string in Python is a variable when you assign it a sequence of characters, like ASDF, GHJKL, something like that. All right. That means now A is a string. A represents a word. Well, it doesn't just have to be a word. We can have spaces in here, and that's fine too. But A is what we call a string, and it represents characters. It represents letters. And we can easily say if we want to print that out, save. Let's run it. And of course, it just prints out whatever that string was that you had assigned to the variable. Okay. We can also look at what the type of A is. So we use type of A. That'll tell us what type it is. And then we'll just print that out. And you'll see that it is indeed a string. Save it. Let's run it. As you can see there, it is a string represented by this character's str, which stands for string in Python. Okay. So that's what a string is. It is this sequence of characters. So what all can we do with the string? Well, one of the things we can do is see how many characters are in a string. And keep in mind, all these things we're going to be talking about strings and manipulating strings and so on and so forth is directly tied to what you have to do for your assignment. All right, so let's get the length of a string. We'll just call it L, and we can do it like len of the variable. And then we can print the L, which is the length. So we have a string. The string is this variable A, and that's what we set it equal to. Then we're going to say this variable L is equal to the length of a string of this string A. And then we're going to print out this length. So let's print out the string, and then we'll print out the length of the string. Save it and run it. Sure enough, there is the string, and it is 9 characters long. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure enough, that's how long the string is. And you'll see later where getting the length of the string is actually very useful. Actually, we'll go and talk about that now when we talk about traversal through a string with a loop. Now, we did last week, a few different ways of doing a loop. You could say something like well, this is one of the ways you can do a loop for a string. We say for letter in A. Do something, right? This looks like a loop that we did last week for letter, and this could be any variable name. We could have called it QWERTY, right? Doesn't matter what we name this, it can be anything. But this part in A has to match the variable name of the string that you want to go through. So if I call this ZXC, then I need to change this to ZXC because I'm specifying which string that I want to go through. So for example, if I had a string ASD and I called it ASD, FGH, and whatever, we have ZXC, let's call it ZXC VBN. All right, so we have those two strings. When we have this in variable name, this variable name is denoting which string that we want to run this loop through. So since I have this ZXC, this is the string that I'm going to loop through. And when we have it set up like this for this variable name, I put QWERTY. Let's just change it to A. Well, let's change it to letter. So that's really what's going to be happening here. So this is saying for letter in this string. Let's do something. Well, for example, let's just print out what letter is. So what's going to happen here? This loop will go through every individual character in this string one at a time. So the first time in the loop, the letter is Z. The second time in the loop, the letter is X. The third time in the loop, the letter is C, and so on and so forth. But for our example, we're just going to print out what the letter is, and you'll see that it'll print out each individual character and one character on each line. And there it is, ZXC VBN. And that is the letters in there. Likewise, we could also do it like this. Let's do this one with the first string. And again, this is kind of a repeat of stuff we did last week. For I in, and here's where the length of the string can come into use. So the length of this string. And do something. All right. This is just a loop like we used last week, except here we're using indices. Here it's referencing the letters directly, and here it's referencing an indice. I use I. Again, you can use whatever name you want to put here for this variable. I like using I. And so how do we access each individual letter? We have to use the string name, and then inside the brackets, it's which character we want to access. So whenever I have this for loop set this way for I in the length of this, the length of this was, well, now it's 6 characters, right? The length of that is 6 characters. So what this is going to do is, I'm sorry, I messed up. In the range, I knew I was forgetting something. I'm sorry, I need the keyword range there. What this has to do is this will count from 0 up into this length -1. So if this length is 6, which it is, there's 6 letters, then I will be 0, then I will be 1, then I will be 2, I will be 3, I will be 4, and I will be 5. Each time through the loop, I is these values one at a time. Okay. And so to access each individual letter, we can have the name of the string, which is ASD. We have the brackets and the index of the letter that we want to access. And these letters are actually numbered. And the numbering system starts at 0. So A is letter 0. S is letter 1. Oops. S is letter 1. D is letter 2. F is letter 3, and so on and so forth. So what we're saying right here is print this string at index, and as I said, I goes from 0 up until 5. So let's print this out. We'll delete this out here so we don't get the prints confused. Save it, and it should print those letters one at a time. And sure enough, it does. A, S, D, F, G, H. So that's 2 ways to go through these strings and access an individual letter at a time. I kind of prefer this way because it's kind of shorter to think about. I don't have to worry about the indices or anything like that. I can just say it like that. All right. Let's take out this extra string as we do more stuff with these strings. So that's how you can loop through a string. Okay. Let's talk about loops and counting. Right. So let's say we want to know how many times, let me change this. I just put a bunch of random letters on there for that string. Let's say, how many times does the letter H appear in this string? Right? How many H's are in the string? Maybe that's useful for some reason, right? Well, I don't know. I can look through there and it's probably like 2 or 3 or 4. I don't know. Let's say we want to count how many times the letter H appears. Well, first we need a variable to keep track of how many we have counted. And so when the program gets here, so far we have counted 0 H's, right? Now we're going to run this loop through, and each time we get one of the letters. Well, let's do a check. Is that letter H? If letter equals H. Do something, right? And so if the letter is an H, then we have counted one more H, right? And then after the entire loop has finished running, let's just print out how many H's we found. Save it. Let's run it. And there are 4 H's in that string. Let's see. Let's make sure it's right. There's 1, there's 2, there's 3, there's 4. There's 4 H's in the string, so it's right. So that's how we can count up how many instances of a letter exist in the string. That's what we're talking. What I mean when we're saying traversing through a string and doing counting, loops and counting, right? This is a loop on that string, and we're counting something, right? And in this instance, we just counted how many H's there were. In your assignment, there's more interesting things to look for and count, but this is just counting how many H's are in there. Right. Let's look at string slices. Let's make this shorter again, make it easier to work with. All right. So a string slice is basically a subset of the string. It's a portion of the string, not the entire string. And the way you can denote a slice is, say we can have a new variable, let's just call it AAA. It doesn't matter what you call it. And we designate that we want it to be a subset of this ASD string, right? And how do we do that? We say it's coming from ASD, and then in these brackets, we tell it what portion of this string we want it to be equal to. Like if we want it to be a single character, we could just put the single letter 0, right? So if we print AAA, that should just give us the very first letter, right? Run it, and it does. It prints out the A, which is the first letter. We can get the second letter, which is 1. That should be an S. Run it, and sure enough, it prints out the S. Okay. Now we want it to be more than one letter. We want it to be multiple letters. Well, let's say we want it to start at 0. And where do we want it to end? So that's this notation we have here. We have the brackets. We have the index of where we want to start. And then we have the index of where we want to stop. But it's +1. So for instance, if I wanted the first 2 letters, right? What indexes are these? Well, A is index 1. A is index 0. S is index 1. So if I wanted the first 2, then I want to start at 0. The last one I want is index 1 because that's the S. But, and you have to, and this is not unique to Python, all programming languages kind of work like this. You have to add 1 onto this number. So it's really 2. So that when I see the 2 here, I'm not accessing index 2 because index 2 is the D. We're indexing 2 minus 1, which puts us at the S. So if I save and run this, now the string is going to be AS because I'm telling it those are the letters I want it to be. Run it, and there it is, AS. Likewise, I could say start at 1 and go to 5, not 56. Go to 5. So what should that print out to us? Well, we're going to start at index 1, which is right here at the S. We're going to go up to 5 minus 1, so it's going to go up to index 4. So that's 1, 2, 3, 4. So that should print out this right here, SDFG. Let's save it. Let's run it, and there it is, SDFG. And of course, the nice thing about this is we can change this original string however we want, and we don't have to modify any of the other code. It still maintains those same positions in the string. Let's run it, and now those letters are SKJH. The thing you must be careful for, let's make this a shorter string again. is putting in numbers that are outside of the range. And what I mean by that is, we can start at 0, and what's the highest number we can put? How many indexes are in here? Well, this is index 0, index 1, index 2, index 3, index 4, index 5. So if we put 6 here, that should get the entire string, right? Because 6 minus 1 is 5, and the 5th index is that H. Let's run this and make sure it prints out that whole string. Save and run it, and it does ASDFGH. What happens if we put a number here that's too big? For example, 7 would be too big, right? Because there is no index 6 in this string. There's index 0 through index 5. There is no index 6 or anything above it. So what happens if we run this? Oh, well, it should have crashed. Well, I think in Python 2 it would crash. We can put something really big. All right, I guess Python 3 was smart enough to figure it out not to crash anymore. In Python 2 it crashes. But generally you don't want to put numbers here that are outside how big that your string actually is. Likewise, well, not likewise, but another thing we can do when we're doing the slices is we can actually use negative numbers. Meaning if we want to start at index 1, if we want to go to not the last, but the next to last, what is the G right there? The G is 0, 1, 2, 3, is index 4, so we would put a 5 there, right? So that should be SDFG, right? Run that. There it is, SDFG. But we had to figure that out by counting how many letters was in the string, right? Instead, we can use a negative number here, which means I want to count from the end of it. If we put I think it's a -2, will get us to the G. Let's save it and run it. Oh, nope, I put 1 too many. -1. Save that and run that. There we go, SDFG. And that way we don't have to count how big the string is. So if we keep going, this will still be, save it, this will still be this entire, well, it won't be the entire string. It'll start at index 1, and it'll go all the way to the next to last index. So we don't have to worry about how big the string is anymore. That's what good the negative numbers are there. Let's save it, run it. And sure enough, it starts at SDF and ends at AAWW, which is right. So that's what we call string slices, and that's how we can get a subset of the string that we're interested in or that we're working with. So another thing to be cognizant about is strings are what we call immutable. And what do I mean by immutable? It means you cannot change the content of a string. You can make a new string. You can concatenate strings together, meaning put them end to end. But you cannot change a string once it already exists. And what do I mean by that? Remember, if we did this right here, ASD, and we said, this index 0, index 0 is the first character, right? That should be the A. We just print it out, right? Let's check it. And it is, it's the A. But since a string is immutable, meaning we cannot change the value of a string, we cannot do this. All right, this is accessing that first letter in the string, and this is trying to change the first letter to something else. But we can't do that in Python. You can't do that in Python. So let's save it and let's run that. And look, It crashes. The string object does not support item assignment. And it tells right now it's on line 5 of my file is where the problem is. So line 5 is right here, and it's saying the string cannot be changed. This is trying to change a value in the string, and we can't do it. So once you create a string, you cannot change that string. You can make new strings. For example, if we really wanted to change the first letter to a Q, let's say we had this string and we really wanted the first letter to be a Q instead of an A. Well, we could do this. We could say the string is now equal to a Q plus the rest of the string. And we can specify the rest of the string with a string slice. ASD, we want to start at index 1. And one thing I didn't mention when we talk about string slices is if you leave one side of this colon blank, it'll assume either the beginning or the end of the string. So if I leave this side blank, it assumes I start at the beginning of the string. If I leave this side blank, it assumes I mean to the end of the string. So put a 1 here. What is this doing? This is saying I have this string. Now I'm going to make a new string. It's this. I can use the same variable. I can use a different variable name. Either way is fine. But I'm now saying instead of it being this variable being this string, I'm saying this variable is now the letter Q plus this string, but specifically a slice of this string. And the slice starting at S and going all the way to the end of the string. So if we print this out, that will work. And you see it does. I have basically replaced that A with a Q. It's a little bit of a long-winded way to get there, but it stems from the fact that strings are immutable, meaning their value cannot be changed. So again, can't do this. You can't do that in Python. So we resort to things like this to change individual letters in a string. Actually, I'm sorry, it's not even changing the letters in a string. It's making a new string, that looks like this. All right. Let's talk about string conditions. What I mean by string conditions is whether something is true or false. And we use that in our while loop, and we use that in our if statements, right? Let's start using actual words in here. Let's use my name, Dan. All right. This is A, string B is Joe. All right. So let's say we want to know alphabetically, does Dan come before Joe, right? Or the other way around. So just like we have in previous if statements, when we have mathematical comparisons with numbers, you could also compare strings. And you could do it, we say if A is less than B, then print it is, whatever. So what's this saying? If A is less than B, what happens here is Python does a alphabetic comparison, right? It says, does Dan alphabetically come before Joe? And so this should print it. It is, because Dan is alphabetically before Joe, right? Let's save it and run it. It is. So let's make an else statement. Else print. Let's just print yes and no. All right. So we've already seen that A does indeed come before B. Yes. If A is A greater than B, this should print no, right? It's kind of the direct opposite. A does not come alphabetically before the B string. Right? And you see it prints no. And we can use all of our normal mathematical operators. We can use less than, we have greater than, we have greater than or less than or equal to, we have greater than or equal to, we can have equal to, and then we can have not equal to. So let's do this one. If A is not equal to B, that's obviously going to print, it's going to print yes, because A is not equal to B. That's if we're checking. And there it prints yes. So, but if we name them the same, then obviously this is going to print no, because that is false, right? There we go, no. Of course, if we change it to equal, this will print yes, because A is equal to B. They're the same alphabetically. Is Dan equal to Daniel? And now they start the same, obviously, but Dan is not equal to Daniel. So it prints out a no. How about this? Is that Dan equal to this Dan? What do we think? The answer is no. Uppercase letters and lowercase letters are different. And actually, if we put, let's say, is A less than B, put Dan and Dan. What's going to happen here? Which one comes first, the lowercase letters or the uppercase letters? It's no. So A is not less than B. And what does that tell us? That tells us that uppercase letters, when you're doing alphabetic comparison, uppercase letters come first. So we can say, so now if we put Dan here and lowercase Dan here, now this should be yes, right? Because the uppercase letters do come before the lowercase letters. Yes. And that goes for, mismatching of cases as well. You can mix the cases. Save. Yes, because of the uppercase letter. Well, let's say we just want to know, actually, let's have the user input a name. Let's have name equals input, enter a name. All right, have the user input a name. Now, let's see if their name is Dan. Is their name Dan? So we can say if name equals Dan. Then we're going to say yes, it is, or no, it's not. Save it, and let's run it. Enter a name, Dan. Yes. Because I entered Dan, and the name, which is Dan, is equal to Dan. Of course, now if I put uppercase letters, it's going to tell me no. Right? Because uppercase D in Dan is not the same as lowercase. So what if you don't care about that? What if you care that it's the same letter, but you don't care if it's uppercase or lowercase, right? There's actually two methods that you can use to check that. There's a thing called, we have the string, and we can say dot lower. This is actually calling a function with this string, meaning make all of the letters lowercase. Now it doesn't actually change the string, but it's saying for this comparison, use all lowercase letters and compare it to Dan. Well, let's just see what happens without the comparison. Let me show you the upper and lower without doing the comparison. So that's the name. We'll print name. Then we'll print name dot lower. And then we'll print name dot upper. What each of those do, this prints out the name as it was input. And let me put print name one additional time. You'll see why in a second. So this will print out the name they typed in. This will print out the name they typed in, but in lowercase. This will print the name they typed in uppercase, and then this will print out just the name again. And I do this second printout so that you can see, even though I've done this lower and upper, it doesn't change the original string. Because as I said before, a string is immutable. You can't change the letters of a string. So let's run that. So if I put capital D, little a, capital N, you see what I typed in is this. In all lowercase letters, it's this. In all uppercase letters, it's this. And then the original string is still what you originally typed in. So how's that useful? Is if I want to know if their name is Dan, and I don't care if they use uppercase or lowercase letters. So I can say if the name dot lower is equal to Dan, then print yes, else one print no. So now, if no matter if I use upper or lowercase letters, as long as I put Dan, regardless of upper or lowercase, it's going to be yes. So let's run it. First, enter some random name. You know, that's not Dan. How about now? Lowercase Dan, yes. Uppercase Dan, yes. Mixed case Dan, yes. Another mixed case, yes. So that's how we can look and see if the strings match, but you don't care about upper or lowercase. Conversely, I could have used upper here, but then my comparison would have had to been all uppercase letters, right? Let's save it, run that. See, it still works. What you have to be careful with, though, is if you do upper or lower, make sure you don't do something like that, because that'll never be true, because you made all of the letters uppercase, but in your comparison you have a lowercase, and that's never going to happen. Put that, right? No. Even if I put it exactly like it looks, was it DA little n, DA little n, it's still going to say no because it's doing the comparison with all uppercase letters. Okay. A couple more things to look at. So let's talk about string functions. You know, we've mentioned through several other videos and stuff, functions that you are built into Python, or functions that you create yourself. Remember, we've already used one so far. We printed out the length of a string. You know, length is a built-in Python function. So that, you know, this will tell us how many letters are in the name. Dan, you know, there are 3 letters. There are actually a lot of built-in function. Well, they're not built-in. Somebody else wrote the code for it. But there are a lot of functions you can use based on strings. And this really goes for any type, but we're talking about strings now. So what did we say this will do? I'm not going to worry about inputting it a name now. Let's just say, actually, let's just make it Dan. All right. So what is the type of the name? You know, we did this at the beginning of the video. The type of the name is string, right? Run it. Sure enough, it is a string. So how can we get Python to tell us what types of functions we can use with the string? Well, we have this thing, this built-in function called dir, and then the variable. What this is, it stands for directory. It's a little bit misleading for Python, I will admit. But this will tell us all of the functions we can use on a string. And it's actually going to be kind of a long list. And it'll just print them out for us. What are all the different functions we can use? Again, this will print out the type, and then this will print out the different functions we can use with a string. Save it. Let's run it. You see here, we got a whole bunch of stuff, right? Right off the bat, it told us what type it is still. It's still a string. And it tells us all these different string functions we can run. Don't worry too much about the underscore ones. You generally don't want to be using those. But let's look at the non-underscore ones. Starting right here. So we can, there's a capitalize, there's a case fold, center, count, encode, ends with, expand tabs, find, format. There's the upper that we used. There's the lower that we used, right? There's this title. There's is upper, is title, is space, is printable. All these different functions you can use. Now, what do each of them actually do? I don't know off the top of my head what all of them do. Let's take, for example, this find function. What does find do? Well, we can do one of two things. We can either go on the internet and type in a search engine Python string find. It'll probably take you some documentation you can read. But if you don't have that, we can use this other Python built-in function. That's called, we're going to print out, it's called help. And then you put in the name of the function that you want to get help for. For us, we use the type. Instead of using the variable name, we want to use the type, which is string. And str is the short for that. And we know it because when we print out this type here, it tells us the type is str for string. So string dot the name of the function. So we want to do find, right? That's what we want to figure out. What is that doing? So let's save it and let's run it and see what happens. And look what happens here. This tells us, oops, I didn't mean to scroll like that. Let me run it again. There we go. This tells us what that find function does. It returns the lowest index in S where substring sub is found, such that so on and so forth. It's a little convoluted, maybe, but it's very descriptive. And then it returns -1 on failure. So what find is actually doing is looking in the string to see if it contains another string. Now I use this specific example of find for a reason, because you'll actually need to use this on your assignment. And we'll actually do find in a minute. Let's look at the lower and see what it tells us it does. Save, if you run it. Lower, return a copy of the string converted to lowercase. And we already knew that from my example, but this is just to show you, it tells you what that function does. So that's how we can find out what functions are available to a type and then find out what that function actually does. Of course, you can always just put in a search engine, and look up documentation, and that's fine too. But this is another way. So let's talk about the find for a minute. So let's read the find one more time. This is the find. So you see it's the string dot find, and then these are the parameters you give it. Sub, blah, blah, blah. It returns an integer. So saying return the lowest index in S where substring sub is found. So what this does is it tells us where in the string does a letter or another string exist. So let me put in my full name. Well, my first and last name. So we'll put I is equal to name dot find. What string do we want to find? Let's find D, and then we'll print out I. Okay. So what this does is it finds where in this string is this letter located, at least the first instance of that letter located. What index is it? And then I'm going to print that out. And by looking at it, we can clearly see that a D is the first letter, that's index 0. So this should print out 0. Quit. And sure enough, it prints out 0. All right, let's find an S. Where does this? The first instance of it is right here. What index is that? That's 0, 1, 2, 3, 4, 5, 6, 7. That's index 7. So this should print out 7. And sure enough, it prints out index 7. What if we put in X? Well, there's not an X in the name. And so the documentation told you that if it can't find it, it returns -1, right? So let's run that. Sure enough, it returns -1, and that's because there's not an X in the name. So how can we, in that name, how can we tell if it contains another string? Well, let's go back and have the input again for the name. Input, enter. That's descriptive enough for me. So let's say I want to know if Dan appears anywhere in their name. So we can have if name.find Dan, name.find Dan equals -1. Actually, let's put not equal to -1. So if the find is not -1, then that means it found it, right? Found it. Else print didn't find it, right? So we'll have the user enter a name. We're going to do a name.find looking for Dan. If that find is not -1, then that means it found it somewhere, and we're going to print found it. Otherwise, it didn't find it. Let's run it. So if we print it and put in Dan, of course, it found it. If we put in Daniel, it found it. There's DAN in there. If we put in Joe, didn't find it because Joe doesn't contain Dan. If for some reason their name was Joe Dan, it found it because even though it didn't start with Dan, it found Dan somewhere in there, right? And again, if they put something that doesn't have Dan in it, then it doesn't find it. What this isn't taking into account right now is what we talked about before with the upper and lower case. The Dan didn't find it. DAN didn't find it. But if we want to take into account upper and lower case, we have name dot lower dot find. So what that does is gets this name in all lowercase letters and then looks for the lowercase Dan. Save it and let's run that. Now I've put in lowercase Dan found it, uppercase Dan found it, mixed case Dan found it, Billy Bob Dan found it, because there's a Dan in there somewhere. So that's how you can find either one specific letter or a sequence of letters, another string inside of a string. Let's see if there's anything else to cover. I think I've hit everything for the content for the week. Let me see if there's anything I want to add for the assignment, and then we'll talk about questions you may have. Password meets secure passwords. You need to make sure the length is right, and we've already talked about the length of the string. You need to see if it contains the UMGC substring. That's kind of what we did right now. And then you got to see if it has the hashtag symbol in it, and it can only be at a certain location, right? So all the things you need for your assignment have been covered in the video, in the Zoom session so far. So I'll go ahead and open it up for questions. Again, it doesn't just have to be for this week, it can be for any of the other weeks as well. So the floor is open.
Hey, sir, this is Will Selby. I two quick questions. So for the thing we just covered, couldn't we also use the in command if we changed the string to all lowers and then said if those all lower string that we're looking for is in the string that we're searching? Is that another way to do it?
Yep, there's many different ways to do a lot of things in Python, but that's one thing. And for the other people in the session, what he's saying, we could say if Dan in name.lower. Let's delete this stuff there. We can also do that. So this is saying, is this string found anywhere in that string? And remember, you need to do the dot lower or the dot upper if you care, or excuse me, if you don't care about the case. You know, if you specifically want it to be, you specifically want lowercase, then like that. But if you don't care if it's upper or lower, generally do it like that. But that works as well. Let's save it and run it. Of course, you put Dan, found it, uppercase, found it, this, Dan. You know, it's in there too, somewhere right about there. So yes, that works as well. There's lots of different ways. So and it's fine to use that one.
Copy. Yeah, I just wanted to make sure that I was doing an acceptable entry. The second question about the actual assignment itself is, I got everything to work, but the way I did it, it only discovers the first error within the syntax. Is that going to work, or does it have to find every single error and report every single error that was found?
Give me 1 second to read it closely. All right, the assignment doesn't specifically say, so as long as it reports an error, if there is an error, that's fine, even if it's the first error it finds. But let me say this though. So have you ever went on a website making a password, and you type in your password and you think it's complex, but it says your password needs an uppercase letter. So you go in there, you type in a new password, make sure it has an uppercase letter. And now it says, well, now your password doesn't have a special character. Okay, so you fix that. And then it says your password isn't long enough, and then you fix that. So the assignment doesn't specifically tell you to list every single thing wrong with it. I think it's a good idea for real world practice, because if I type in a wrong password, I want to know everything wrong with it so that I can fix it the next time I type it in, instead of fixing one thing at a time. So if you don't do that, that's fine. I'm not going to count against it. But real world programming, it makes sense to do that.
Copy. Then could you give an example of a statement, I guess, that could allow you to do multiple error finds, I guess? I was having trouble with trying to figure it out. So
okay, so let's just say we're entering this name, and we want to make sure, is it greater than 3 characters? Let me start over. The name, whatever name I input, needs to be bigger than 3 characters, and it cannot contain Dan. Okay, so we say if the length of the name is less than 3, then something is wrong. Well, let me just print that. Print error here. All right, you can come up with more descriptive error messages than this. Okay, so that's one check. So I said the name has to be longer than 3, or at least 3, right? So if the name is less than 3, then it's an error. Okay. Well, I also said it cannot contain Dan. So if Dan in, not in, no, that's right. If Dan in, was it name.lower, print, this is another error, right? So if we do that, let's run it. I put in Dan. That actually fails both things, right? This is another error. Oh no, it passes the first check, so that is at least 3. Let me put it has to be 4 or greater letters. Yeah. So if I enter Dan, yeah, it it fails on the first thing and it fails on the second thing, right? So if I put Daniel, right, that passes the first check, but it doesn't pass the second check, right? So it just has, this is another error. You know,
Copy.
if I had a fourth check, the tricky part you got to figure out is if it passes every check, print, it's a good name, right? But you can't just leave that there, right? Because that's going to print out it's a good name no matter what happens. So what you need to come up with is, how do I say it's good only if it passes every single check? That's the tricky part you got to come up with.
Roger. I think I know how to do. I think I see what I did wrong. I appreciate it.
Okay. All right, I'll hold on for just a few more minutes. If you have any questions, please ask them. If not, I will be sending a link out to this video sometime a little bit later this evening whenever it gets uploaded, so you can rewatch it if necessary. Again, you can always email me anytime you want with any other questions or assistance you may need.
Hey, appreciate it, Professor. Take it easy.
Hey, Professor Brian Newton here. Just wanted to ask a quick question. So the assignment says that we have to output when the password is invalid. One of the invalid things is, for example, like it has to be greater than and less than a certain length. Do we have to have a statement for each of those, like one statement for your password's too short, one statement for your password's too long? Or can we have one statement that says, hey, your password doesn't meet this requirement, which is whatever the number of characters we decide?
I'm okay if you just say your password is not the right length. It needs to be between X and Y characters. So you can put that on one line. You just, for the error message, you kind of need to state though that this is how few and this is how many that it can be.
Yes, sir. Thank you.
All right, I'm going to go ahead and close it out. Everybody have a good evening.